So guys, let's look into different algorithms or approaches to do those assembly tasks. So first and foremost and simple one amongst them is this greedy approach. As we have seen in our algorithm sections, that a greedy approach is where you are trying to get to your objective without kind of taking into different factors that might hinder your speed or that might cause you some damages. So but you are just aiming at your objective, so you need to get it. So this is the approach where in assembly what we do here is we compare all reads and or contexts in a pairwise fashion. So all reads with one another, align them, and then in the ends, towards the ends of those reads, you will find the overlaps. So you merge the sequences with one another so that they overlap with each other, and this overlapping is the best. And you keep on repeating this process until you find no more overlaps, or until you find the best overlaps, and then you can put those reads which are overlapping with one another into the shape of those contexts. So this is how it can be elaborated. So we have read 1 and then we have read 2, and they are overlapping with one another. So for example, they have like 200 overlaps with one another. Then read 3 and 4, they have like 150 overlaps, and there is one where we have this 2 and 3, they are also overlapping with 50. So when we put them together, we can get some order. So where we can have 1 here, 2 here, and then there goes 3, and then there goes 4. So in this way, we can have, by using these overlaps, we can put them together into those contexts. So there is simple overlapping. The advantage of this is that it is suitable for small size genomes. They drastically simplify the graph by only considering the high scoring edges, only the edges where we can have those high overlaps. And we may discard overlaps after contexts are extended. Obviously, this simple and a greedy approach has some disadvantages. The disadvantage is that they can detect false overlaps, and we can have high scoring ones that are maybe coming from repeats. So here is the places where this algorithm tries is kind of failing. There is another limitation that graph traversal may cause algorithm to stuck in local maxima, which produces suboptimal results. I will introduce this local concept of local and global minima and maxima in some later sections, but just have a brief overview. So you are getting to a big objective, and sometimes you get something similar to it. So it's not that your real-time objective. So for example, you are trying to go and climb some big hills, and you climb a small hill and then you believe that that was the biggest among that area, but actually it is not. So that kind of issue is, or that kind of scenario is where you are stuck in the local maxima. So this algorithm, while using those overlaps, gives you an assembly, and it then keeps on building onto that. So it thinks like the solution it's giving you is the best one, is the perfect one, but actually it may not be the real solution, but it stucks over there and it does not come out of it. Okay, so this local maxima will increase the gaps between the contexts in the assembly. There are different uh, packages or the programs which are based on this greedy approaches. One is SSake, we have VCake, and we have this Shark GS. So what we have seen so far here is that greedy approach is the simplest one, but it does have some issues.